Hello everybody, this is the third video clip for chapter 2 of our Calculus for Business 2. Okay, previously what we have done is about the we have looked at the optimization problem, which is to maximize or minimize the objective function under the constraints given, and usually all the constraints will have you the so-called feasible region. Okay, will give you the feasible region. Sometimes, okay, occasionally your feasible region will be empty. That one will give you no solution for our optimization. However, there can be some non-empty feasible region. Okay, there can be two kinds. Okay, which is bounded. If it is bounded feasible region, then your min and your max will occur, and it will occur at the corner. Okay, I mean at one corner of your feasible region. If it is unbounded feasible region, then your min and your max may occur. Okay, depends on your objective line. Okay, it may occur, but if it occur, either min or max will be at the corner again of your feasible region. Okay, even though it is unbounded. We get. So for example, let's look at this one. Okay, this is the some of the word problem that will be pretty long. Okay, and then you need to have your again patient to read the problem. Okay, so this one, a toy manufacturer preparing a production schedule for two new toys. Okay, so you got two new toys, which is called the widgets and widgets. Okay, it must use the information concerning their construction times given in the following table. The first toy, let's call the widget. Okay, you are going to, I mean, for one unit of your first toy, you are going to operate your machine A for 2 hours, machine B for 1 hour, and you have your finishing product, I mean, for another 1 hour. For the second toy, the widget, you are going to use your 1 hour for machine A, 1 hour for machine B, but 3 hours for finishing product. Okay. The available employee hours per week are as follows. To operate machine A, it cannot go beyond 70 hours. For B, it cannot go beyond 40 hours. And for finishing product, it cannot go beyond 90 hours. If the profit on the first toy widget is $4 and the profit for the widget it is $6, then this is the question, right? How many of each toy should be made per week so that it will maximize the profit? Okay, and what would be that maximum profit? Okay, so what is your objective? Of course, I mean your objective, so let me just write down here first. Okay, your objective, it is your to maximize your profit, right? Okay, so what determine your profit is the number of your first product and your second product, right? So let us say that we produce your first product for X unit and you produce your second product for Y unit. So for 1 unit of your first product, it will give you $4 for a profit. So if you produce X unit, you're going to have 4X as your profit. And for the second product, each one of them will give you $6 profit. So if you produce Y unit, you have another 6Y for your profit. Okay, here's 6Y. Okay, so let's say that this one is P of XY, which is for your profit, and the one that you need to find the maximum value. Okay, and I mean, because your machine A cannot operate beyond 70 hours, so it means that to produce 1 unit of your first product, you are going to operate your A for 2 hours. If you produce X product, you are going to use 2X hour. Same thing occur for your second product. Okay, 1 unit will use machine A for 1 hour. Y unit will use your machine A for 1 Y hour, and together it cannot go beyond 70. This one the same thing, okay. X product of your, X unit of your first product will use X hour of machine B. Y unit of your second product will use Y hour of machine B, and together it cannot go beyond 40, okay, for B, right, 40. And for finishing, for X units of your first product, you are going to finish it in X hour. For Y units of your second product, you will use 3 hours, 3 Ys to finish it, and then it cannot go beyond 90. So all these are the constraints. Okay, this one cannot go beyond 40, this one cannot go beyond 90, and of course your X and your Y, because it is a number of product that you are going to produce, so it's going to be non-negative. So let us write down again all the objective and the constraint. So the objective, it is your pxy equals to 4x and 6y. The constraint, okay, it is your, of course, x and y must be non-negative, and the 2x and y equals to less than or equals to 70, x and y less than or equals to 40, and x plus 3y less than or equals to 90. Okay, so you are going to draw all these inequality, okay, and find the feasible region. Let us sketch the feasible region by starting with the x and the y axis. Okay, so let's look at your first inequality. If your x is 0, your y is 70. So let me just 2, 3, 4, 5, 6, 7. Okay, so here's 70. All right, and then if your y is 0, your x is 70 over 2, which is 35. So let me do 1, 2, 3, 4, and 35 right here. So it is this one, and of course I'll just concentrate on only the first quadrant, because your x and your y, it is non-negative, so it means that the one that you need is only the one on the first quadrant. Okay, so you got two regions, okay, above or below. So the one below passing through this point 0, 0. So as you plug in, you have 0 less than or equals to 70, which is okay, right? So it means the region that you choose will be include this origin. So it means that you are going to use the one below. Okay, use the one below. And for the second one, if your x is 0, your y is 40. So 1, 2, 3, 4. So it's right here. Let me use the red one, 40. And the same token, if your y is 0, your x is 40 as well. So let me use this one, and it is this. Again, above and below, the below one has 0, and as you plug in 0, 0, you have 0 less than or equals to 40, which is okay. So it must include this particular origin. Okay, so it means that you are going to need the one below. So if you have only these two lines, the region under consideration will be this quadrilateral region, right? However, you have another one, which is x and 3y equals to 90. If your y is 0, your x will be 90. So it will be pretty long. This is 4, 5, 6, 7, 8, 9. Okay, and if your x is 0, your y is 90 over 3, which is 30. So it will be somewhere here, let me just use the dash line first because we are not sure whether this black line will go above this point like this, or will go below the point, or will go passing through this particular point. So we really need to find all the intersection. So let us start by this intersection. Okay, this intersection between the blue and the red. So it's right here, the blue and the red. So you can just simply do the subtraction, right? So you have your x equals to 30, and then immediately when you have your x, your y is 10. So here, okay, your x is 30, your y is 10. Okay, how about this one, the black and the red here? The black and the red is right here. So you again do a subtraction. Okay, so to have your 2y equals to 50 and your y is 25, and again, as you know your y, immediately your x is 15. So here it is 15, okay, this point, and 25, and the position is right because here is 30, your x, and there's your x is 15, so it has to be on the right of this red one. And here your y is 10, there your y is 25, so it will be go above. Okay, so even though this point is not that important, but let us find this one between the black and the blue. Okay, the black, the blue is 2x and y equals to 70. The black is x and 3y equals to 90. So you multiply by 2, so to have 2x and 6y equals to 180. So you do a subtraction to have your 5y equals to 110. So your y, it is 5, so you have 22, and your x is a what? As your y is 22, so your x is 90 minus 66, which will give you 24, right? Set. So this one, this point, your x is 24, your y is 22, okay, which is okay, right? It is in the right position. So your black line must be this one. You need to decide whether you are going to use the one below or the one above. Again, the 0, 0 is here with the below region. So as you plug in, you have 0 less than or equals to 90, which is okay. So the region must include this origin point. So you need to do the one below. So here, this one, you need the this region, the below one. The red also the below region. The black is also the below region. So it means that the region that you're talking about, the feasible region, is the one bounded by these 5 points. 1, 2, 3, 4, 5. Okay. So let's call this one as A, which is 0, 0. This is B, which is the black one, right? So your B with the black one, it is 0 and 30. And your, this one can be your C, this one can be your D, and this one, it is the blue one, which is your E, can be 35 and 0. All right. So let us calculate the objective at each and every point. Okay, for example, P at A, of course, I mean your P is this one, so your P at A, it is 0. Let me just do the P at 0, 0, which is 0, of course, or you can say that it is 4 and 0, 6 and 0. Your P at B, it is p at 0 and 30, so it is 4 and 0, 6 and 30, so you got 180. Your p at c, it is p at 15 and 25, so it is 4 and 15 and 6 with 25. Okay, so 4 and 15, you got 60, right? And 6 with 25, you got 150, so together you have 210. Okay, how about your p at d, which is the point 30 and 10, so you have 4 with 30, 6 and 10, so you have 120 and 60, so a total of 180. And e, which is the point 35 and 0, so you have 4 with 35 and 6 with 0, so you have 140, is it? So which one is the maximum? Here is the maximum, right? So you need to produce, okay, so don't forget, here's your x, there's your y, so you need to produce the first toy, the first type of toy, which is what? The so-called widget for 15 units, and the widget for 25 units, in order to make your maximum profit of what? $210. Okay, $210 under the operation constraint, or under the production constraint. Okay, all right. Okay, so let's look at another example. Okay, this one is about the diet formulation. So if a diet formulation, okay, a diet is to contain at least 16 units of carbohydrate and 20 units of protein. Okay, so this is the one of the condition. It says that a food A, so you have the first type of food, contain only 2 units of carbohydrate and 4 units of protein. The second type of food contain 2 units of carbohydrate, 1 unit of protein. If the food A cost $1.20 per unit, and the second food B costs only 80 cents per unit, then this is the question: how many units of each food should be purchased in order to, of course, you need to minimize the cost. And what is your minimum cost? Okay, so the unit of food A, let's say that you buy X unit and you buy your food B by Y unit. So your cost, okay, which we may say it as a C of XY, it is 1.20 cent X and 0.80Y as your cost, right? Because this one is cost per unit, this one also cost per unit. You buy X unit, this is how much you need to pay. You buy Y unit, this is how much you need to pay. Okay, so this is the cost, and you need to minimize your cost. What is your constraint? Of course, I mean the first constraint, again, you are going to buy your X and your first kind of food and the second kind of food, so it must be non-negative. Okay, and it is about the carbohydrate. You need to have at least, okay, so at at least. What does it mean by at least? Okay, at least it means that you need to have greater than or equal, right? At least 16. So it means it can be greater than. So it means that for the carbohydrate, so let's see, what is the first food contain? It contains 2 units of carbohydrate, and you buy X of the food A. So for carbohydrate, you got 2X, okay, 2X. And for the food B, it contains also 2 units of carbohydrate, so you have another 2Y. So, okay, and together it cannot go below 16. Okay, so this one is for a carbohydrate. How about for your protein? It says that your protein must be greater than or equals to 20. So for the protein of your A, you got 4 protein, so you buy X unit of A, so you have 4X. For the B, you have only one portion of protein, but you buy Y of your food B. Together it must be greater than or equals to 20. So this one is for the protein. Okay, for the protein. So this is not that difficult, right? Because you have only two major constraints. This constraint is for, to let you know that it is in the first quadrant. Okay, so the first one, it can be simplified to be X plus Y greater than or equals to 8. So you can do the 8, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if your X is 0, your Y is 8. If your Y is 0, your X is 8 as well. So you have this one. Okay, and as you test for your 0, 0, you have 0 greater than or equals to 8, which is a contradiction. So it means that your region must not include the 0, 0. So the region, it will be the one upward. Let's look at your second one. Your second one can be simplified to 4X and Y greater than or equals to 20. If your Y is 0, your X is 20 over 4, which is 5. So here, 5. And if your X is 0, your Y is 20. So it's going to be beyond, okay, this one. Okay, here's 20. All right, and you need to find the intersection between these two. So what is it that you do? You do a subtraction. All right, so you got 3X equals to 12. So your X is 4, and then your Y is 4. So here, 4 and 4. Let me just write down here. Okay. What will be the region that you need? Okay, for the red one, it is the one above or below, right? Again, this one below including origin. So if you include the 0 and 0 here, you have a 0 greater than or equals to 20. Again, it is a contradiction, right? So it means that the region that you like is the one above. So here it is this one and this one together, right? So this one is the unbounded region. This unbounded region. Okay, from here. All right. How many corner points that you have? You got 3 corner points. Okay, here is your A, there is your B. Okay, so this one, your B, it is your Y is 20, your x is 0, right? And over here, okay, your x is 8, your y is 0. So let's call the C. Okay, and the cost, the objective, okay, the cost here, let me rewrite it a little bit. It is y equals to negative 1.20x over 0.80 and plus the C, the cost here. Okay, so it means that your slope is negative, so it's going to be something like this. So as you're going upward, okay, you hit oh sorry, this C must be over 0.80 as well, but as you move it upward, okay, your C will be more and more, so the cost will cost more if you go upward. So you need to go downward, okay, in order to get your minimum. And of course the minimum will be one of your corner here. Okay, so the minimum exists because of this one, okay, because of the slope. So the minimum cost exists, okay, at some corner. Okay, so let's see your C at the point A, which is 4. So it is 1.2 times 4 and 0.8 times 4. Okay, so it is 4.8 and right, is that correct? Okay, so it is what, 8. How about your cost at B? So it is 0 and 20, so it's 1.2 and 0.8 with 20, so it is 16. And for the last one at the point C, but this C is the cost, okay, so it's a C at 80, which is 1.2 with the 8, and this one the 0.8 with 0, so you have 9.6. So which one is the minimum? Here is the minimum cost. So you need to buy 4 units of the food A and 4 units of the food B. Okay, this one will give you enough nutrition, I mean the carbohydrate and protein, okay, the minimum that you need, okay, the protein, and also the minimum cost, okay, for this kind of buying food will be $8. It will be $8. All right.